Hello all, welcome to this online lecture recording sessions in data science. So in this lecture, we are going to see the deep learning concepts in this dataset. So this dataset name is what? Mnist Dataset. Mnist Dataset. So let me talk about this Mnist Dataset. So Mnist is a university which is you can see, you can refer this Mnist full form, where who is working with this particular type of data set, or who have developed this data set. Okay, so in this data set we have the images. Okay, so we have images and we have label for this images. Say suppose if this image is 1, then I will have the label as 1. Okay, so if the image is 5, then I have label as 5. Okay, so like this I have the images. So this will be my x value and this is my y value. That means here what I will do, I'll give x samples, nothing but an image. Then I'll need to get an output. It need to see that image, particular image, and it need to identify what kind of image it is that. Okay, so that we are going to see with the help of this Mnist dataset. Okay, right. So now this dataset consists of what things? What things we need to know about this dataset before starting the implementation, building the model and everything. So let us discuss about the deep learning concepts. So generally the deep learning concepts, it involves ANN, CNN and RNN. Okay, these three techniques. So these three techniques entirely consist of deep learning: advanced neural network, convolutional neural network and recurrent neural network. So advanced neural networks, so when we need to apply these concepts, ANN concepts, when our data is in the form of text or any kind of data, we can apply ANN technique. But if it is purely image, or if it is generally image purpose, so if our data set consists of image, then we can apply CNN technique. Okay, so images is used for CNN. So RNN techniques. So RNN concepts and RNN techniques, when we will use, when our data set consists of time forecasting data set, time forecasting or time series, or in text cases also we can use RNN concept. So time series, time forecast or time series or text data, we can apply RNN. If it is images, we can go with CNN, and if it is less storage or less samples, we can go with ANN, irrespective of whatever it is, the input samples. So these are the three concepts that are there in the deep learning concept. So now you understood the problem statement, right? So we are giving one image, and we are trying to predict it. So now you tell me which concepts we can apply ANN or CNN, right? So because there is handwritten digit recognition, handwritten digit recognition or prediction, means digit is there, right? So text is there and image is there. So the samples are also less. How many samples are there? We'll have 10 samples. So we'll have 0, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the image will be 0, the image will be 1, the image will be 2, the image will be 3, the image will be 4, the image will be 5. So here in the form of text it will be there, 1, 2. Okay, so in the form of text it will be there. So in this case 4, 5, 6. So it is like this. So with 10 samples. So 10 samples means what? We can go with ANN or CNN, right? So right now I am going to show ANN techniques with the help of code sample, Mnist data set using ANN technique. Okay. So before this, I like to share the prerequisites means what are the things that we know before uh, uh, looking into this video or looking into this coding sample. We need to know Python, we need to know some concepts of NLP, and some concepts about CNN, and some concepts of ANN. Okay, so we need to know about some libraries also. So these are the things that you need to know before looking into this video. Okay, so even though if you are comfortable in doing with the help of this video, if you are able to execute, that's fine. So but concept wise, I suggest to go through those concepts before looking into this video. Okay. Okay, see, now we have chosen that we are going to apply ANN techniques for this deep learning for deep learning topic for this particular data set, right? So this MNIST data, where we can find how we can do, right? We can go with two ways, right? We can directly manually download from the Google the data set and upload it and work on that and build a model, test it, and so on. The steps like how we'll do with the machine learning steps. Okay, so in this also we have some libraries that are built. So let us talk, before starting this, let us talk about the disadvantages of machine learning. The disadvantages of machine learning, drawbacks of ML, why deep learning, or drawbacks of ML. So when there is a machine learning, then why we need to go with deep learning? Why we need to go with it? First point, when it is the case of huge data set. If our data set is too large, it may be 5 GB, 10 GB, 15 GB, 20 GB, then our models like KNN, linear regression, logistic regression, and classification techniques, all those things will not work properly. Okay, so when there is a huge data set, our ML algorithms fail to give a correct prediction. Okay, then second point, if our data is in the form of images, then also our machine learning algorithms cannot work on the images data set. There may be some few, very few ML algorithms that can work on images, because the machine learning concepts are also developing day by day. So if our data set consists of images, then we can go with the deep learning concept. So in these two cases, you remember that we need to go with deep learning instead of ML. And I also shared what kind of different types of deep learning concepts are there: ANN, CNN, RNN. Right now we are going to look into the ANN technique on the MNIST dataset. Okay. So what are the steps to build this? The steps will be similar to the machine learning algorithms. So if you are aware about machine learning, if you are aware about the steps that are there in machine learning, you can it will be an easy task for you working on this ANN technique. Okay, so first step is loading the data set. Load data set. So how will I load the data set? With the help of manually by downloading it from the Google, or with the help of libraries that are there. So this MNIST dataset is there in the TensorFlow. Okay, so here some new libraries that can be discussed here. One is TensorFlow, other is Keras, and the other one is PyTorch. Okay, so TensorFlow is the basic one that involves numerical ones and array forms in the form of tensors. Okay, so on top of tensors, we'll use Keras. Like in HTML and CSS, how is HTML, right? On top of the HTML, we'll apply CSS, right? So in the similar way, here also in deep learning concept, these three libraries are very important. And in this TensorFlow, we'll apply on top of the TensorFlow, we'll apply Keras. Okay, directly we can't apply on top of TensorFlow. We need to apply Keras for better purpose. Okay, so then we'll also have the PyTorch library. So these three libraries are required for the deep learning any deep learning problem. Okay, right now we are going to see TensorFlow and Keras. Okay, so let us see. So first we need to install the TensorFlow and Keras library. Okay, so let me install it. So pip install TensorFlow. So pip, here I would like to some people will write pip, simply pip, and some people will write exclamatory mark and pip. So this one we can use in the VS Code command prompt, and this pip we can use it in the Google Colab. Okay, and Jupyter Notebook also. Okay, so now since it is a Google Colab, I am using exclamatory mark and pip. Okay, so I'll run it. So I will run it. So after running it, let us see. So it is ready. Since it is I already run this code, it is taking less time. And while running, also make sure there are different run times. So here you need to go to change the runtime type, and you need to select CPU, GPU, and TPU. Here right now I am selecting GPU because the training process will be happening very fast when compared to CPUs are very slow processors, so that may take some time. Okay, so if you use GPU, it will be faster than CPU. We can also use TPU also. So right now I'm using GPU. Okay, so I will save it, change runtime as GPU. So the training process and everything will happen very fastly. Otherwise it will take some data set may take days also, 1 week, 2 weeks, hours also. It may be hours, it may be days, it may be so long if it is so long. So since so that's why I'll go with GPU. Okay, so now I'm importing TensorFlow.Keras. So TensorFlow and Keras, I am importing it as TF. TF will be the alias. Every time I can't call TensorFlow.Keras. So instead I will call TF. So I'll also use some visualization also. So for visualization, what will use Seaborn or Matplotlib. So right now, since it is a normal visualization, I'll go with Matplotlib. And my process also involves image, right? So image will be in the form of array. So any image if you take, it will be the form of array. It may be array, and this array will be scaled up to 0 to 255. Okay, so if the value is 0, that means no, it is an empty. Okay, if the value is 23 or somewhat any number, random number, that means here some data is present. Say suppose I'm drawing one image like this. So in this image you tell, if I take this image and represent it, how will I get? This can be represented in the form of array. So since array concept is involved here, all the images are represented in array, we need numpy. Okay, if array concept or matrix is involved, we need numpy. If it is loading the data set, pandas. So I am not taking pandas. Why? I am not downloading manually. If you want to insert the data set, we need pandas. If you want to load the Excel file or CSV file, I need pandas. So I am not loading anything. So I am simply just extracting it from the library, right? So I am not taking pandas. So I am taking only numpy. So why numpy means it is involving images, and those images are represented in the form of arrays. So if it is like this, so if I represent this, what will I get? 0, 0, 0, 1, 2, 3, 4, 5, 5 zeros. In the second row, what? 1, 2, 3, 4, 5, 5 zeros. Here next you see 1, 2. These two are empty because no image is there. So, and if you see, look into this, in the third box, you see some image is coming, right? So this image can be given with some value between 0 to 255. It can be 150 or some random value. So next box you see there is an image, right? So it may be some value. Okay, and next box it is 0, no image. So if you look into another box, again you will see another image. Okay, so and the next there is no empty. So because there is no image, all the values will be the 0. So this is how it looks if I represent in the form of array. All the images are represented in the array, and if the array is pictorially visualized, it will be like this. So wherever the image is there, there we will get the normal values. Wherever there is no image, we'll get all the values as zeros. Okay, and here the depending upon the higher values have high clarity, lower values have low clarity. The image size in terms of pixel, it will be low. Say here I'm having 150, that means here the image will be brighter. Okay, 140 compared to here in this box, the image is somewhat brighter. In this part, another part, it is 140, means it is somewhat dimmer, or it is having less brightness when compared to remaining box. Okay, so this is how in the form of array the image can be represented. Okay, right, you understood, right? So it is in the form of 0 to 255 scaling, and how it is represented, how the values, depending upon the values, how we can tell, right? So now we will see what are the data set. So we are going to see in TensorFlow what data set it is having. So first we need to import TensorFlow underscore dataset as TFDS. So we are importing all the data sets that are there in the TensorFlow. Then I want to build the TensorFlow dataset. So for that I am looking into it. So what are the different kinds of data sets? So if you have taken Seaborn also, it has some data sets. So now in TensorFlow, these all are the data sets that are present in TensorFlow. So in this you see where is Mnist dataset. There are many. There is Iris dataset also. There is Iris dataset, Titanic dataset, WordNet dataset. See, these all are. So we can look into some popular datasets that are there. So you can see here, all these are datasets. You can count it, some more than 100, I think, datasets that are there in TensorFlow. So simply you need to run that. So using a command, using one line, you need to run the dataset and load it and work on that. You need to pull it from the particular library. So ImageNet. So we need to see Mnist dataset. So look into it. So COVID-19 dataset, you can see it. You can look, if you have patience, you can, with the help of patience, CIFAR 10 dataset, CIFAR 100 dataset, with the help of patience, you can look, study and look into each and every dataset that is there in the TensorFlow. Okay. Let me see, where is Mnist dataset? C, D, E, F, G, H, I, K, L, M. Yes, Mnist dataset. So it is here. So now I'll copy this. So now out of all the datasets that are available in the TensorFlow, now I'll use this particular dataset. So for that, what we need to do? We need to write one statements to use that particular dataset. Okay. These all are datasets. Yeah. So we are defining one variable. In that variable, we are trying to add that dataset. So we are defining one variable Mnist. In that Mnist, we are writing tf.datasets.mnist. So this is my dataset name. So this is my dataset name. So if I run it, it will be executed. Okay. So if I want Iris, I can take Iris also. See, we can experiment. So you can rewrite this Mnist and take any of the dataset named here. It should be exactly, if it is small, capital means capital. So directly you can copy it and add it here. Okay. So you can experiment by checking it, by taking this code sample and all. You can check it. So if possible, I'll give this code file in the description also. Okay. So now after loading with the help of this variable, I want to display how many training samples, how many testing samples are there. So inbuilt everything is there. So just we are checking it, how many are training, how many are testing. Okay. So if I look into it, so xtrain, xtest, ytrain, ytest, Okay, X test, Y test. So how many total samples are there? 70,000 samples. So there are 70,000 samples in the Mnist dataset. So in this 70,000, 60,000 are used for train purpose and 10,000 samples are used for test purpose. Okay, so 60,000 are used for train samples and 10,000 are used for test samples. So in this train samples, what do you have? X and Y value. So what is X, what is Y? The image is X. So suppose this is an image with a digit 6. The Y value will be the text. Okay, so this is X value and Y value. So on together we can conclude X train, Y train. Okay, X and Y. So in test also we have X and Y. So what are those X and Y? Say suppose here 8 as a digit. So this image as X and below is a text. What kind of it is? 8. 8 means it is Y label. Okay, this is output. So this is training sample, this is testing samples. So how many are there? If you look into it, so this I'm not doing manually. So it is already trained, already it is there in the TensorFlow. Just I am trying to visualize or look into it with the help of the Python functions and Python commands. I'm just looking into it. So internally it is split, or else you can download the dataset and you can manually split 50,000 samples, that is the 50,000 and 20,000 like that. You can 80 20 70 30 like that, you can split it and you can work on them. So since it's internally splitted also, with 60 sample as training and 10,000 as testing, so I am directly using it here. Okay, so so now after loading it from the TensorFlow, what I will do, I'll check each and every sample. Say suppose in 60,000 sample, training are 60 right? Training are 60,000 right? Test is 10,000 right? So X of 0, X of 1. So for this corresponding X, there will be Y of 0, Y of 1. This entire thing is X. So here there will be a text. So this is Y. So if I'm talking, if I'm calling X naught means, so in the 60,000, the very first sample I'm talking. So it may be anything, right? We can check it. So here, if you look into it, I can notice it is 5. That means the very first sample in the Mnist dataset out of 60,000, it is 5. So for this image, what will be the Y value? 5V, right? So like that. If I'm talking about X1 means the image. Y1 means the label that will be there to that particular corresponding image. Okay. So now you see what is there. So now you see I'm taking X train of 0. What it is showing? 128 in the form of 28 cross 28. So in generally it is good to represent in the 28 cross 28 pixel. The images will be represented in the 28 cross 28 pixel for a good visualization in the display purpose. Okay, so that's why n-dimensional array, ND array of 28 cross 28. So how this image should represent? It should represent it in the form of array, right? Okay, let us see. So here you can see X train of 12 means what you are getting. X train of 12 means out of in training sample 12th sample. Okay, in training out of 60,000 12th sample. How the image is like this. See, you can guess what kind of image it could be. So it is having, see, I have mentioned if it is having value means there is an image. Depending upon the value, it is better or dull. Okay, so like this image. So this, if I'm looking at this, I'm not coming into a conclusion. See, like this means it may be You can, if you're familiar with this, you can, with the help of this array dimensions only, we can we can see what kind of image it is. If it is coming like this, means it is very difficult for a user to come to a conclusion what kind of image it is. So for that purpose, we use CMAP function. CMAP function is used to convert the array format of image into an pictorial form of an image. So beside that, you write CMAP is equal to gray. So now what happens, you see. So now what happens? So this will be, this entire array format will be in the form of picture. So it shouldn't be print, it should be plot. Okay, shouldn't be print, it cannot be print, it should be plot to visualize. Okay, so that is a mistake, it is there in this code. Okay, so next line of code you can take it. So you can take it. So here what I will write, I can take that block of code and you can use it here. Which sample? Which sample? 12th sample, right? X train of 12. You can give it here. X train of 12. It will be converted. plt.show means it will be shown. It will be shown to the user. User need to see, right? So for that purpose, plt.show. Okay. plt.show is used to see the picture. And CMAP is used to convert the arrays form into the pictorial form. So after clicking it, already it is there. The code is also there in below. I think you can run that. See, it is 3. Yeah, if you look into this image also, see, it is somewhat, the arrays are like this. Okay, the arrays are like this. This is a 3. Okay, the image is 3. If you are using CMAP for that particular function, you are getting able to see. So here also it is there. Okay, understood, right? So like that you can check for random samples. So next I am checking for 59,000. Last sample I am checking. So first sample I was seen, and the last sample also I am trying to see it. So what it is 8. So X train of 59,999. So that means I am getting 8. So next, if I want to visualize it, what I need to do? PLT. So PLT is used to visualize. So directly if you are using X train, if you want to visualize in the numerical or array format, you need to do print statement of that particular training sample. Okay, so here you can see I used print statement to visualize this particular training sample. So if I'm using PLT means what? Directly instead of array, that image will be shown. Directly image will be shown. So here last image. So the above steps same. If you understood the above step, repeat it. So understand the above steps and try to write the code for the similar way by changing the sample. Okay, so the last sample is 8. Okay, so now this is an image, right? We understood, and we have this is what image means. What image? There are two things, right? Image and label. Since it is an image, what we will call it is an x value. This x value is from the training. This x value is from training. So that's why this is x train of which sample? 59,999. So for this corresponding x train, there will be x test also, right? X test of 59,999. So what I need to get here, if I'm using this statement, I'm getting an image that is 8. So if I'm using this statement, what I need to get? I need to get the label below this particular image. So what I need to get? 8, right? So let us see. White. So white train, it will be white train, not X Y test. So this is training samples, right? We have X train, X test, white train, sorry, white X test, Y test. I'll write it here. X train, white train, X train, white train, X test, Y test for testing samples. So if you are using any sample from testing side, you can check with respect of X and Y. If you're using any random sample from training means you need to use X and Y for that particular. So since I have used X train, so here also I need to use Y test. Sorry, Y train, right? Y train. This is training sample. So that is what I'll use. Y train of 59,999 means it is showing the what kind of text is there below that image. It is 8. Okay, so we are converting the text into np.unit of 8 means it is coming in 8. So similarly, np.unit unit 8 is nothing but it will convert into the numerical format. Unit 8 means, so actually it will be in the form of text. Okay, Y train of 2, it is 4. So second sample will be 4, first sample will be 0. Sorry, second sample, 1 means second sample, 0 means first sample, 59,999 means last sample. So Y train of 2 means third sample. So because we are starting from 0, right? We are starting from 0, 0, 1, 2. So 2 means our third sample. So that is what we are seeing here. Okay. So now what we will see, we have seen individually, right? So now let us see group wise. Say suppose some 50 samples together, some 100 samples together, like that. So for that, what we need to do, how you can design the code. If you understood the above code, you can design it for the multiple samples. So same logic, same block of code that is there to visualize each individual. So that is visualize individual sample, that you need to put it in a for loop. So that individual samples, if you put it in the for loop, that for loop will be repeated for 50 samples or 100 samples or 70 samples, whatever we want. So same code, I am writing it in the for loop. So this, why I am using for loop? Because I want those commands only know. So the commands which I used to visualize individually. So the same commands, if I want to apply for multiple images in the particular data set, so I can go with for loop. Okay, so here I used for loop to visualize 50 samples. Okay, sorry, 100 samples. So 100 samples you can see. So if you count here, so now let us talk about the this for I in range 100. Okay, so now what is this 10 cross 10 means 10 rows 10 columns. If I put here 5, sorry, 100, no, so 100 can be divided into 20 into 5, right? So 20 rows, second one will be the columns. So I need to get, instead of like this, I need to get somewhat like this. Okay, it is getting like this because this is in this screen it is clumsy. So all 20 images cannot be fitted into one row. So again we need to reduce. You can edit this code by giving by editing this. Okay, 20 cross 20, instead of that you can change this randomly. You can change this samples, the above samples figure size. You can reduce the figure size. If you reduce it to below 20, I think it will work. You can try it. It will definitely work. I have tried also. You can work on that. So now if you look into this, we have taken 10 cross 10, right? So 100 will be so for 50 samples, let us take. So for 50 samples means I can use 10 cross 5. 10 cross 5 means 10 rows, 5 columns. Yeah, see, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is the rows. So 10 rows are there. If you count it, we have 10 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows and 5 columns. 1, 2, 3, 4, 5. So 5 columns. So 50 images are represented here. So these values you can change it randomly with the help of subplot. So how many samples you want to represent, that you can give it in the range function. So next, why we need x ticks and y ticks? That means we need to get a label here, right? So x ticks and y ticks are used to, so see. So if I uncomment this statement, what I will get? Will not get the labels. So what is there? We will not get the labels here. So for 5, it need to show y value also, right? So for that we need to plt dot y ticks and see we got, but some are missing. I think we need to use x and y. If you use both, you'll get all. See, we can with the help of this code, you can do hit and trials and observe how the code is getting changed, and then you can learn the code manually. Okay, so see, now I am getting below also. So if I'm using x ticks, these dimensions are gone. So if you observe, these dimensions are gone. Previously, if I'm not using x ticks, it is coming like this. So the ranges, it is coming like this for x and y values. So I'm removing for the x values for the x axis and y axis also. For the x axis and y axis also I'm removing. So for that I need to use x ticks and y ticks. So below I want to print the corresponding value. So that's why y train of I. So for every x train of I, I need to print y train of I. So label is the string that I am giving, and beside label I need to get the particular y train sample. So I am getting here y train sample, y train of I. Okay, so if my sample is first sample, so I'll get, for the first sample I'll get y train of 1. Okay, so like that for 50 samples we can note it down. The font size of how much this font size, this label is coming, right? Y label is coming, for Y output is coming, right? That font size should be 15. So this also you have understood. So you have understood CMAP also previously. CMAP, these two lines are there in the previously when we have visualized individually. Okay. So this entire thing is visualized in the 20 cross 20. That means the screen space. I'm talking about. So see, when I'm scrolling, so you can do hit and trials these values, and during this you can study all these things, the concept which I have discussed, these things you can know. Okay, so now what I will do, so I have visualized some 50 samples and 100 multiple samples together. So now what I will do, so I'm checking the shape. So it is 28 cross 28. Generally it will be in 28 cross 28. So now what I have done, so I have done here no pre-processing, nothing, everything is pre-built. So we are just visualizing the samples. Okay, multiple samples and individual samples together. So next what I will try to do, directly build the model. No pre-processing, no loading, just extract it, visualize it, and just build the model. Okay, so we are building the model here. Build the model. Okay, we are building the model. So building the model, what we need to do, so we are using building ANN model. So if you look before this, what are the things that we need to know for building an ANN model? So any deep learning model involves inputs, okay? Input layer, input, hidden layer, and output. So these three things we need to implement any deep learning model. So whether it is ANN, CNN, or RNN. So if inputs we need, hidden layers we need, output we need. So here if you see, I'm taking input layer, hidden layer, and output layer. So for if you look into the, if you recall the concept of the entire process of the deep learning model. So how, I think that is discussed in the other lecture session. If you are free, go to that lecture session and see how the working procedure happens in case of any deep learning model. So inputs and weights will be getting summed up, bias will be getting added, and then activation comes, and then y value will be there, and then back propagation will be repeating until and unless we get the correct values. Okay, so that is the general procedure for any deep learning model. Okay, so in this our model we are input, hidden layer, and output. So for inputs, do we need any activation function? So for input, no need of activation function. So for hidden layers and outputs, we need activation functions. Activation functions. So which kind of activation functions? So for hidden layers, we can use ReLU activation function. So for outputs, we can use any other activation function depending upon the classification problem. If it is a multi-classification, we can use softmax activation function. If it is a binary classification, we can use sigmoid, okay, activation function. So accordingly, you can select it here. So activation function is, since it's a multi-classification, I'm going with softmax. You can define here other activation function also. You can check it with sigmoid activation function instead of softmax. So since it is a hidden layer, I'm using ReLU activation function. Okay, so input layer. So input layer will be flatten or dense. There will be two layers to construct, two concepts, two layers that you need to know before constructing the input layer: dense layer and flatten layer. Okay, so I want to just construct a flatten layer. Okay, so I'll use flatten. You can use dense also. You can check it with that whether it is working or not. But in case of hidden layer, I'm using dense. Layer dot flatten, layer dot dense. So my input is in flatten layer and my hidden layers and output are in dense layers. So you can refer this, what is dense layer and flatten layer. You can go through it. You can detail concept wise by referring any blocks or anything. Okay, so TF dot layers flatten. Okay, so this is how we construct input layer, hidden layer, and output layer with the help of activation function. Okay, and we are just constructing a blank model. So model dot sequential. Okay, so instead of sequential, you can use other functions also. That also you can check it whether why we are using sequential here. Why not the other function that is there to build ANN model? So I think you have known these three lines of code. Then comes the we need loss functions, right? We need loss function and we need an optimizer and we need a particular matrix. Okay, so how do you select a loss function? For multi-classification, I have already shared, we use sparse categorical cross entropy. So we use binary cross entropy for binary classification. So this is, remember, this is multi-classification because 0 to 9, how many samples are there? 10 samples are there. 10 means more than 2. If it is 2, it is binary. If it is in the case of cat or dog, means you can go with binary classification. So multi-classification works for binary also, but binary will not work for multi-classification. That you need to remember. Big bowl can accommodate small things. Small bowl cannot accommodate big things, right? So in the similar way, you can assume like that and you can look into this concept. Okay, so binary means 2. So So for multi-classification, you can go with sparse categorical cross entropy. Okay, for binary classification problem, we can use binary cross entropy. So optimizer also, there are different optimizers we can use. So right now I'm selecting Adam optimizer. So stochastic gradient and Nestro accelerated gradient. So all those things, optimization technique, you can check it. But out of those, Adam is the simplest one. It is value will be 0.01, I think. So this Adam optimizer, I am using it. And matrix also, how we need to select? If it is a multi-classification, which matrix you will select? You can select accuracy or AOC curve and ROC curve. If it is binary classification, we can go with precision recall and F1 score and all those matrices. But since it's a multi-classification, and we can go with accuracy, or accuracy also you can't go sometimes. Since it is 10, okay, it may give. But if it is 100 samples, 150 samples, 200 samples, how the matrix will be this much big, very, very, very big, right? 200 samples means it will be not sufficient, and the values and all, everything, we cannot visualize it properly. Okay, 200, 500 samples, multi-classification with 500 samples, 1000 samples means how it will be there? Very, very big matrix, right? Very, very big confusion matrix. So in that case, you can go with AOC curve, ROC curve in multi-classification. So since it is 10 samples multi-classification, we can go with accuracy. Okay, you can go with accuracy confusion matrix. Okay, I hope it is clear in building the model. So after building the model, what we will do? Building the model, what we'll do? We will test it. If it is working fine, we will save it. Okay, we will test it. So build the model. This build. So while building also, we can do scaling. Without scaling is also fine. Why we need scaling? I think I have discussed. Scaling is used to reduce the values. So all those will be in the matrix, right? With a range of 0 to 255. That we need to reduce in the form of some lower range of values. So I suppose 0 to 1, 0 to 1, or 0 to 1, or 1 to 5, some defined range we need to define. So we need to contrast the size of the particular array. Okay, that's why we need scaling. Scaling will be doing by 254. With the other than 255 also, we can do with 64, 32, 64, 122, 255, like this. You can check it. So with the scaling can be done with 32, 64, 122 and 255, like this. Randomly also you can do scaling. Okay, so in scaling also we have min max scaling, standardized scaling. So again, it depends upon the problem statement which type of scaling technique you use. Okay, scaling is used to reduce the size of the array. Okay, so now what we will do, after building the model, we will train it. So while training it, if you observe it, how we are building. So already I am working on training samples. 60,000 training samples are there, no? So I am building the model, I am training it and creating it I am implementing in a practical form by building it. Okay, already there 60,000, but I am trying to build them. Okay, and then I'll test it. So for the testing purpose, I think I have discussed train, test and validation. So here I am taking train, test. Okay, X train scaled, Y train, X train, Y train, and X train scaled we are using because our X train samples are modified to X train scaled. Okay, X test samples are modified to X test. Okay, so that's why X test scaled and Y test. So here we are giving validation data. So validation data I am giving it as X test scaled and Y test, and epochs I am giving 15. What is epochs also we will discuss. So X train scale, Y train are there. For this corresponding X samples, this is the Y sample. Okay, so X, Y is over. Then this is the validation. So these three things are required for training any machine learning or deep learning. This is how you will split it. Okay. What is epochs? Epochs means these samples are divided, right? These samples, how many times it will train? Okay. It will divide it into batches. Say suppose 15 batches. It will divide. Epochs is 15, right? So for the 15 times, this 60, this particular samples will be tested. This particular samples will be trained. So that is why 15 is there. Okay. That is why 15 is there. So we can see all those things while running the code. See, epoch size is 15. So that's why 15 times it will be trained. So all the samples that we are giving in the for this training model, how many samples? 1875 samples. So 1875 models, how many times it is getting trained? So first time it is getting trained. Again those 1875 models, again for the second time it is getting trained. Third time it is getting trained. Fourth time it is getting trained. Fifth time it is getting trained. So some samples we are taking and we are training it. Okay. So how many samples? 1875 samples. So that how many times it is getting trained? 15 times. So for every time you can see 9 times finished. So same samples it is getting trained for 15 times. Because more times the model gets trained, the better the results it will give, right? So that's why I am giving epoch size as high. So you can give any number of epoch size, while training. Okay. So training gets over. I think it's over, right? So if you observe at every time, the accuracy is getting increased from 90. At first sample it is 90, then 97, 98, 99. So it is increasing. 99, 99.80, 99.84. Again, if you see here 99.78, it is decreasing. So we need to stop here. So we need to stop here itself. So because it is decreasing here. So if you see, the loss function is also decreasing. Okay. So value loss. Okay. So you can study this. So as accuracy is increasing, what happens? The loss case and value accuracy and value loss, how these values are getting changed? Are they increasing or decreasing? During training, you can observe this from samples and you can come to the conclusion as the accuracy is happening, what my values are, whether they are increasing or decreasing. We can come to the conclusion and you can look into it and study. We can observe. You can come to some observations. You can conclude some observations from the training samples. Okay, now my model is trained. Now I need to predict. Predict what? Test samples. Test samples. I think here I have given X train and X test. Okay, I think text scaled samples I'm giving it here as a Y prediction. So what happens? So Y test of 0. Y test of 0 is nothing but 7. Y prediction of 0. So Y test of 0 is, so testing sample of 0 is what? Now so see now. So every training is happened. Now what you need to do? Predict. We need to predict it, the testing samples. And those predicted values we need to compare with the test samples. So predicted values Y pred and Y test can be compared. So if they are same, then okay, our prediction is good. The test samples are predicted correctly. Okay. So my test sample y test of 0 sample is how much? Y test of 0 sample is how much? 7. Okay. Y test of 0th sample is 7. So similarly y prod of 0 will be also should be 7. Okay. Then only our prediction is y prod is correctly predicting the y test samples. Okay. So y prod of 0, how much we need to get? 7. Okay. We have got that or not? We can see it. We can see it. Okay. We can see it. So y prod of 0 is nothing. It will commit in the form of array only. So that we need to, if you want to visualize, argmax command you can use, or you can use a cmap function, plot. If you want to, I have already discussed this. I think I have already discussed. If you want to visualize in the numeric format, we can go with argmax. If you want to visualize in the form of text format or in the array format, you need to use matplotlib and plotly, as we have seen earlier. So you can refer it the code samples, and you can look into it. So similarly, go with y prod of 10. So y prod of 10 and y test of 10 is how much? 0. Okay. So this y prod of 10 is 0. Okay. That means it is correctly predicting or not, we don't know. So we need to check it. So test samples. So we can write the code. So y test of 10 is how much? We can visualize it. We can it is 0, right? So this y prod of 10 is should be also, this array value should be also 10. How we know this is 10? You can convert this array into image format using cmap and some other techniques that I have discussed. You can try this. You can try this from this code and try to visualize it also. Okay. So next what we will do, we will evaluate. So how the predicted values and the test samples, are they correctly predicted or not, with the help of accuracy. We have selected metrics as accuracy, right? How much accuracy it is giving, we can calculate after plotting the confusion matrix. So this is my confusion matrix. So now you tell me about this confusion matrix. So what are these values? So this is my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the rows also, these are columns, right? 0 to 10. So any confusion matrix will have representation of like this. If there are 3 samples, means 3 cross 3. Since it is a 10 cross 10, we are rows 10, columns 10. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9, 10 samples. 0 to 9, 10 samples. So 10 cross 10. So now you tell me. So first one is 0 samples are predicting 0, 969. So total how many are there? So total how many are there? 10,000 means 100, right? 1,000, right? 1,000. So out of 1,000, whether it is 1,000 or not, how we will know? So you add all those values. 969, 970, 72, 74, 75, 76, 79, 80, 980. Okay, 980. So if you add this also, what we will get? 10, 100, 1,000. So you add all these things also. What value? 1128, 28, 1130, 30, 33, 34, 35, 1135. So we can check it. So what values? So total how many samples are there? So how many values are predicted correct, how many are predicted wrong, by what value it is predicted wrong. So 0 values are predicted as 1. How many? 1 sample. So out of the test samples, how many test samples we have taken? I think 10,000, right? We have taken which one? Y test np dot argmax. So y test samples. So 10,000 samples. Out of 10,000 samples, y test means y train, y test. Y test means 10,000 samples, right? 60,000 are training and 10,000 are for testing, right? So in 10,000, 969 are predicted as 0. Okay, and remaining are predicted as, how many remaining are predicted as 1? 1. 0 is predicted as 1. 0 is predicted as 2. How many samples? 2. 0 is predicted as 3. How many samples? 3. Okay. Similarly, if you take 5, this row. So 5 is predicted as 5. How many times? 860 times. So 860 samples are predicted correctly. So 5. So if the image is 5, it is predicted as 5. So if the image is 5, how many it is predicting 3? 17 samples are been, because I will write 5 as like this. Some people will write like this. Some people will write like this. So whatever they, so but model, how the model is understanding that, we need to remember it here, and we need to check it. So the 5 is predicted as 3. How many times? 17 times. So like that you can study this confusion matrix and see how many types of wrong samples and how many types of diagonal. Always remember, diagonal will give you diagonal values, prediction values will give you the correct value predictions of from the confusion matrix. Okay, from the confusion matrix. So next what you will do, so now we are calculating accuracy. So accuracy is 98. So this accuracy, you can plot this X train and X test, and then you can save the model. So deep learning models are saved with the H5 model. So PKL is used for saving machine learning. H5 is used, H5 extension is used to save deep learning models. So you can name the file name. So I am labeling, I can give the file name as Akhil.h5. That means my deep learning model. So if I'm getting 98 accuracy means that is good, right? That is fine. So then what I can do, I can save this model. I cannot repeat the entire process that I have done earlier. Instead that, to avoid that, I can save this model with the particular extension H5. So now I will run it. I think I need to get it here. So Akhil.h5. So I will copy this file, deep learning model, which is trained, and I will save it here. Okay, so I will save it here. So we got here. So now what we will do, we'll take random sample, random input. We can take random input. From the paint. Can go to paint, MS Paint. I can take, this is the input. So my model is ready. Now I am testing my model. So how will I test? So I am taking this as input. So now I will do what I will do. I will save it. So in order to save, Control S, save image as test sample 1. So this test sample I am saving it. Okay, this test sample I am saving it in the let us save it in the D drive. Please select another. Okay, so you can save this in the desktop, and you can apply it in the, you can check it in the desktop. So let me save it here. Let me save it in the desktop. Okay, so I think it is not getting saved or what. So save it. So you can try it. So you randomly draw a picture and upload it here. So upload it here. Wait. File, save as PNG in downloads. So I'm saving it in the desktop. Okay. So this is what. So untitled file. Okay. You can label it anything. So now what I will do. So now I will go to my code sample. Now I upload that input value. So where is my input? It is in the desktop. So untitled. Okay. So it will get uploaded here. So untitled.png. So this one I'll copy this path and I'll give it as here for testing purpose, and I will see. So if I'm seeing that file is visualized like this. So now you check it. This is train, right? So test sample also you check it. So you can check it and you will find the correct prediction. It will predict as 5. If it is not predicting as 5, then we need to look into another sample. We can go with another sample and we can try hit and trial and we can check our model is working or not. So Akhil.h5 is the model. I think here I need to change. Yeah, correct. That's why. Yeah, now you see. I think you'll get. Five. So 5 we are getting. Okay. So now this one y test also, we can write code for y test of 0 and you can see the label should be 5. So this is how you can give random sample for this deep learning model, ANN model, and you can test the samples. So similar way you can same concepts can be applied for fashion Mnist data and CIFAR 10, CIFAR 100 dataset also. So I think below description I have given. You can apply the same concept using remaining dataset also. So this is how the ANN model works. So I think it is clear. The few concepts are covered, and it is we are able to execute it at least one deep learning model in ANN. Okay. So thank you all. So thank you for this opportunity.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.